With the intense curiosity of a planetologist, a person who studies planets, researchers aboard the JOIDES Resolution turn their attention to the planet Earth to discover how it works on a planetary scale. We learn a lot about Earth by studying earthquakes and volcanoes. Most of the earthquakes and volcanoes in the news shake and blow around the Pacific Ring of Fire. Think Mount St. Helens in the United States, the biggest earthquake ever recorded in Chile last year, and the eruption of this submarine volcano near Tonga in 2009, all along the Ring of Fire. In fact, 95% of Earth's volcanic activity takes place around this ring. But a small number of Earth's volcanoes form away from the ring, in a different way, over a hotspot. Expedition 330 is studying the Louisville Seamount Trail, a 4,000-kilometer-long row of underwater volcanoes formed by such a hotspot. A hotspot is an area where hot rock from the deep earth rises towards the surface. As it rises, it expands, melts, then breaks through the crust above it, forming a volcano. But the crust above is actually in motion. Slow motion. As this continues, it leaves a trail of volcanoes. Dr. Anthony Coppers is one of the principal investigators on Expedition 330.
Seamounts are basically like a window into the deep earth processes. Seamounts form above hotspots. But there's a big question out now in the science community, and the question is, are hotspots actually stationary or fixed in the mantle, or can they move around? If they can move around, it gives us a picture of the mantle and the earth as being way more dynamic than we previously were thinking. Seamounts are underwater mountains, originally volcanoes, and most of them are now extinct. The Louisville Seamounts that we're studying are about 50 to 70 million years old now. So they're definitely not active anymore, but they are basically consisting of ancient lava flows and other volcanic products. We are studying 4 seamounts. We are drilling those 4 seamounts and we try to collect lava flows, for which in particular we can study their magnetic signals and their chemistry.